Good morning. There's people up there too. Yeah, so today I'm going to talk about some design matters. And before I start, I wanted to say that, just to tell you a little bit about what this figure is about and why I put it here. This is a Ouroboros, that's one way to pronounce it. It's the serpent who is perpetually in the cycle of it's eating its tail, if you will, and it's in this process of living, discovery, and destruction all at the same time. But there's also rebirth and energy after, So it's not like we want to consume ourselves with worrying about design, but self-reflection and thinking about what we're doing is important. And then to really make and understand about design, we have to get on with building things and understanding and pushing on the boundaries of what we can do. So with that, I want to talk about some design matters. And one of the influences of me has always been Christopher Alexander. And so just want to start with the fact that Christopher Alexander talks about why is design so hard? Well, we're looking for some kind of harmony in what we're doing. And we have control over the context, the form, the structure of our system that we haven't yet designed. And it's hard for us to describe it. So, it's like, wow, how do we ever get anything done? So another influence, and I'm going to talk a lot about heuristics, is from Billy von Kohn. And what we do as designers is use a lot of heuristics. And I want to talk about the nature of heuristics, too. Kohn says, anything that gives me a plausible aid or direction in what I'm trying to solve, but in the final end, it's unjustified, incapable of justification, and potentially it's not going to work. So why do we ever use heuristics, one might ask? It's like, they're doomed to failure? No, but they're not always guaranteed. So this is his book, and I highly recommend that you, if you're into thinking about design philosophy, that you talk about, that you look into this book more deeply. And there's some characteristics of heuristics that it's good to be aware of as we apply them to the design matters that influence us as we make our design decisions. Any heuristic you use is going to potentially conflict with another one. But they're both still useful. So what do you do, right? The whole idea of using a design heuristic, whether it's how I structure my system or think about modeling, or whether how I go about my daily work, it's helping me reduce the time it takes to get something done. And whether I choose to use it or not depends on not some gold standard that's out there that I'm comparing it against the ideal design heuristic, but it's the immediate context that I know about. And it's, as I said earlier, it doesn't guarantee a solution. So let me give you an example just to wrap your head around solutions and the fact that there are competing heuristics. Maybe you're arguing with yourself one day about this was a good design choice, and then the next day after you've done some implementation, you disagree with yourself. Well, that's okay. So let's say you have this problem, and hopefully it's in this sphere of solvable problems. And if you're someone who knows about domain-driven design, and you like rich domain models, your problem fits within that sphere of solutions, so I can use rich domain models and the patterns within that. Oh, great. But it probably also can be done in an anemic way, right? And then, because I like objects, I tend to prefer rich domain models. This is just my preference because of my context of my heuristics, but there's also this transaction script pattern, if you look at Martin Fowler's. And my problem still might fit into that too, right? And so on the other, I drew this in this way because this one is kind of a little faded. I mean, it's not as rich a pattern that I would naturally choose, but I had to be careful because maybe that's all that's needed to get the job done. So you can learn a whole lot if you take your current heuristics that you're using to apply to design problems that you're developing, your preferred set of heuristics, and bouncing it off of other ideas. So let's do a little bit of exploring on that area. So Martin, I gotta have people, Martin says, ways to structure a domain layer, where the domain layer is doing business functionality and validation of data and control of actions that are business related. And patterns of enterprise architecture, he talks about transaction scripts and domain model pattern and the table model when you use active records or all those variants like that. And when I go out into the real world, my consulting, I see people doing stored procedures. And they're building huge systems. I mean, huge systems with stored procedures. And other clients I worked with, we've had a rules engine kind of core of executing and interpreting behaviors. And then there's this pure functional style where it's hard to say where it fits in that spectrum. And there's combinations. I mean, that's what I encounter in the real world. So when I think about this, Martin has this in his book, if I'm looking at something I see, and this is the two axes, and he said it's unscientific, and so I put my, experience of what I saw with stored procedures or database scripts along that line, and it's like, it was really, really hard to change it as soon as it got complex and it went asymptotic. That's why they called me in, right? It's like they needed help. But still, so there's maintenance effort. And this code reuse potential that Martin has in his book. And I think about, well, what about those database scripts? Okay. And then, just to make a point, is that you mentally may come up with, and I've actually used this in courses that I've taught about, is the best fit profile, given design skills and the driving forces that are kind of forcing you to choose some heuristics and go, the project duration, the system complexity, what you thought was the complexity, but we're never certain, or how long that system is intended to last. Yeah, we're right on that one, aren't we? But anyway, the point is, there's always going to be disagreement about what heuristics to apply, unless you're all like-minded folks. And actually, it's probably a good idea to have some disagreement and really to think about it. So given, best fit for what you're doing, let's talk about some other folks that aren't particularly modelers per se, but they have influence in the world. So Paul Graham, made his money, and I don't know that he is actually doing design much these days anymore at all. But anyway, he says, the more demanding an application, the more leverage you get from using a powerful language. So if you got a hard problem, use a great programming language, which is why we all should be programming in Haskell or, never mind, whatever. But plenty, and he goes, plenty of projects are not demanding at all. So doesn't really matter what you do, right? As long as it has good libraries. I mean, that was his heuristic. So let's look at his heuristics and compare them with rich anemic domain models. He says, yeah, use a powerful programming language when you have a complex problem, and it doesn't matter what programming language to use. If you have a simple program, just have something with good libraries. And here we have, well, use a weak domain model when you don't have any rich behavior, and use a rich domain model when you have rich behavior, and transaction scripts when you don't have any modeling skills or time, or you just want to hack it out. All right. So what do I do? Maybe if how does that heuristic of applying the best programming language interact with a heuristic of I want a rich domain model? So one of the things that Cohn says is that heuristics are aggressively competitive. They're always like fighting for each other, and they can overlap, so you really have to sort through this stuff. Let's talk about another one, just to give you an example. I used to teach, well, here's what you should do, and now I'm saying, well, it depends. And it's not because I've gotten older. It's because it really depends on the context. If you're thinking about user input validation from a browser web-based kind of application, how much do you validate in the browser? Do you use a hand-coded style so it's more evident, or do you use a declarative style and annotations and all that stuff so it magically happens without you really knowing what's going on, and it's harder to debug, but it works? Or do you use, the framework classes, or do you, what do you do? And then another choice that we make is if we're validating and checking constraints on whether we're validating input or constraints on whether we want to take an action, which objects are responsible for that if you're using an object? And when are they enforced? And how do you deal with those cross object constraints? So I used to have design recommendations, but now I have heuristics, really because it depends upon the context. I used to say, well, simple edits are in the browser code. And I used to say, and never trust them. But now I've kind of said, don't universally trust browser-validated edits, but reapply them if you are receiving them from an untrusted source. But if you're receiving them from a trusted source, don't be stupid. Don't revalidate. And that's like, wow, I used to not believe that at all, but given certain contexts recently, I do believe that. I'm a big fan of consistency. So if I'm going to say syntactical kind of checks should be done by a framework, then I want to make that the kind of consistency I'm applying and doing richer behavior inside of my domain objects. And be consistent about it. So one of my heuristics is really caring more. I favor consistency over cleverness. I guess that's one way to put it. So let's talk about checking constraints in the domain object. And I taking old examples from domain-driven design just to kind of make my point about it. There's good things about putting it inside the object itself. It's more direct. You know what's going on if I put that logic. So here's an example of order, and this is expediting order. Factoring constraints into an externally named helper method makes it more intentional, and it keeps it within the object, so I know what's going on right there. On the other hand, clutters it with a lot of checking. Now, if that's all it's doing, well, I don't know if that's necessarily a bad thing. But it doesn't have any ability to externally modulate when those constraints are enforced, which you may want to do, if you need that variability. Okay. So, if you do it in separate classes and have that validation done there, well, let's constraints be enforced by some kind of domain service or business object that controls things, that can determine when to check those constraints. And it might be cool, if I need it, to dynamically configure those constraints. But what's going on? So you're making these trade-offs all the time. So back to Billy again. One of the things that he says is, we as designers who want to affect change in the world, we choose the best, and it's okay to say best, from what our potential state of the art, the set of heuristics that we have collected over time, that you're required to choose. And so don't feel guilty if 6 months from now or 5 years you say, man, that was dumb. Because you did the best you could. I mean, we have to move on and move forward and learn from what we're building. And when I use this word SOTA, that's SOTA, state of the art, that's my collection of heuristics. It might be your collection of heuristics that you use. So one of the things that I really like about design patterns that are written in a certain way is that they're kind of packaged heuristics that not only do they tell us, do this, and maybe this consequence will happen, but they also provide a bit of a context. Well, when should you do this? In what situations might this apply? What can I do that usually works? Now, again, it's not always guaranteed, but it packages it in a nice way. Now, whether people like to read patterns in that form, but those that do explain a little bit about that are nicely packaged so that you can, make decisions a little easier. Now, Alexander also talks about the notion of pattern languages that says no pattern is an isolated entity. Great, I used the singleton pattern. I must be really cool. But each pattern only exists in a context, and if you're really trying to get power, you should say, have a set of patterns that work together to solve a certain, that I can apply, a set of heuristics that I can apply that create some kind of consistency. I have to admit that I've been sort of disappointed in our state-of-the-art of pattern languages, because if you look at this pavement here, you'll see that there's some gaps, and pattern languages are an ideal. We're not really there yet. It's not walking me through a set of steps that I have to really think about. I think it's much more messy than that, and there's a lot of gaps and overlap, but it still behooves you to learn about patterns and to think about where they apply and how they work together and where they compete or conflict. So here's some heuristics from Cohn that I think that he is a retired nuclear engineer, nuclear power plant engineer who taught engineering in a school in Texas. So just given that context, he talks about engineering, but here's some of the heuristics he talks about. This is great. Think about this for the nuclear industry here. Solve problems by successive approximations. If you're asked to, as someone who's trying to make change in the world, an engineer that's his definition of that, in a positive way for humanity, always given an answer. So if you have to compute how many people are in this room, for example, and I have 2 seconds, I'll say 20 times 600, 500, I don't know. If I have more time, I'll count. So given the context of when I have to give an answer, I've got to come up with one. And so one heuristic might be multiplying it times the number of seats in the first row, and then there's some, anyway. So you have to give an answer when you are asked to give one. And this is great. Always give yourself a chance to retreat. It's like don't get locked in. That's why Ward Cunningham talks about technical debt is when you haven't reflected your learning back into what you're doing. Use feedback to stabilize the design. So we got to build it before we really understand it. And break complex problems into smaller, more manageable pieces. These are always make the minimum decision. He says, well, don't go leap out into space, just keep going with what you know, but don't believe that it's going to solve everything. And he says, design for a specific time frame. And what he means by your intended lifespan of the product or the thing that you're creating. And I'm glad he says that, having, being a nuclear power guy. Sometimes I wonder about us software folks, do we really understand the time frame of the software that we have? It's so soft we think we can always change it, but it's really hard. So anyway, it was surprising to me when I was reading about his set of heuristics. I go, we use a lot of those, don't we, in the software world, right? Those are just kind of the heuristics aren't necessarily design choices so much as how you approach design as well, or what you do in your daily work, and what you focus on, and what you kind of fall back on in your process and your thinking. So anyway. So one of the things about heuristics is that how do you learn them? How do you figure it out? Well, I think as a kid, when you're experimenting with stuff, you figure that out by experimentation, right? I remember when I was 6 years old and I learned how to ride a bicycle. This is a really dumb example, but it's true. I said, when I started riding a bicycle, I noticed that the spokes kind of seemed to disappear. So looking, well, where'd they go? So I actually put my foot in the spokes while I was riding my bicycle, fell down, skinned my knee, came home crying, and I go, oh, okay. I mean, and so usually, right, so you experiment. But when you're a kid, you may do some really radical kind of stuff. But as an adult or a designer in the world, we learn through writing or completed designs. We read other people's books. So there's this whole body of stuff that we get exposed to. And then there's your own personal cherished set that I won't say you cherry pick, but you have your own garden, right, of heuristics that you've used. And as new ones become useful, I won't say trendy, but useful. Maybe we do them because they are trendy. We add them, okay? And those no longer useful fall out of fashion, right? So, which is okay. I don't want to necessarily make software the same way I did as I first wrote my first Fortran program back in the last millennium, where common was very common, right? That's not a good idea. But sometimes still useful ones fade too. So what I want to do is to take a quick tour, if you'll let me, through some useful heuristics that I think are worth remembering. This is the a plug here. Back in the last millennium, responsibility-driven design, and the start of this millennium, there's a concept that came up with actually observing different role stereotypes in Smalltalk programs that we saw a lot of. Typical behaviors, and I remember writing about this like in the 90s. It was an observation, So yeah, there are things that hold on to information, and there are things that structure and manage relationships, and there are things that perform work on demand, and there are coordinators that react and delegate versus controllers that kind of are more active, and then there are these things that interface and transform between stuff. And that's kind of a good way of looking at it. Knowing, doing, and deciding. So we're like, okay. Those are kind of conceptual stuff that you see in designs. But the heuristics that I used to apply were like, okay, I want to make objects do stuff with what they know, which sort of is compatible with a rich domain model. So, I don't consider it a bad thing that information holders that compute or derive, or service providers that maintain information or cache information to be more efficient. That just seems like a natural, like, duh, why not do that? Or structurers that don't just hold on to relationships but can answer questions about it. They may delegate to something, but you still ask them. And interfaces that can transform. So that's kind of applying that heuristic. And so the heuristics, are design objects to do one thing well that compete against it. Single responsibility principle. And I would have to say that I've spent many years now explaining, well, single responsibility from Bob Martin's work doesn't mean that you only have one method in an object. I don't know how many people I've said, well, how about single purpose? So it's related, cohesion. Anyway. And then the other competing heuristic is make the overall system simpler by having things that do something with what they know is a really powerful heuristic. Those are kind of competing against each other, actually. But I've found a way to rationalize that and explain that to folks. So here's another, this is a book from the 90s, you can tell from the color scheme. But Peter Code and his colleagues talk a lot about structuring and some key concepts that I think have been useful to me, and they've faded from fashion, but it's interesting. One of the things that he talks about, and there's a very simplistic idolized icon here that says, separate out the stuff that varies depending upon the current relationship, and you go, well, what does that mean? And he talks about people or organizations can have capabilities, and so, and you may have, so understanding that relationships and capabilities can change over time, and keep that fluid. This is a very simple diagram of just, don't argue with this design, it just fits on the slide. And I spent a whole summer working on roles and relationships and whatever that could change dynamically for the single sign-on system for a company, and it's really complicated, but you need to really think about separating out those things. That's a very important thing. Another thing that he talks about is that, they talk about in this book, is that thinking about location as something that can be hierarchical or even more complex. So if I think about the gate that I went to the airport in Munich to come here to Schiphol last night, it's a gate in a wing, in a terminal, So there's 3 hierarchies right there, and 20 minutes to walk to. I was in Munich, so. So locations can be hierarchical or even more complex, and there may be different ways of dealing with location that might compete or overlap each other. Having worked in the telephony industry, that was quite obvious to me. It's like geolocation is actually, well, there's many ways of locating. And then the other thing that I think is interesting to think about is events, and I've been doing some modeling with a client on a project where events and determining when events happen in sequence with massive amounts of data and understanding the relationships between events can be really messy. So they can be point in time or intervals, which may be hard to figure out and depend on other events, and they may be inconsistent that you get in data. So anyway, that's just something that is worth remembering. So from a domain-driven design, you might, Eric's book, might talk about this state of a life cycle of an entity. And one of the things that I notice is that, you delete it. It's active, you modify it, it changes states, you get it back in, you may archive it, you delete it, it never gets deleted. from my business. It's like I've never seen it deleted. But another useful thing to think about attributes of domain entities is that you can talk about a good way of characterizing them, to think about what you need to do with verification or all kinds of other state-changing things, or what's important, is to distinguish or think about attributes that are descriptive, not identifying it, but just describe it, versus time-dependent attributes, where I maybe need to keep track of history over time, versus those life cycle state-changing attributes that go through a life cycle to initial to final state. But the world is messier than that, because if those events are inconsistent in the world, you may need to go back and fix things that were, reconcile things with the reality that we now know about. And then some things switch between different states, and that's okay. And just sort of having this way of classifying or characterizing your understanding of a domain entity is actually really, really helpful. So to me, I find that very useful. So here's another. This dates these books. I hadn't realized the color schemes of all this stuff. But how many of you are familiar with problem frames? Okay. So that's Michael Jackson, the Brit, not Michael Jackson, the gloved one. And he talks about his heuristic is really ask deep questions about the hard parts of a problem that you're trying to do. And he talks about problem frames, or really, if you will, characteristic frames that you might see in the world when you're trying to build a system or design a system. And what I did with that, so he had 5 frames in this book, and I wish that other people would think more about framing the kinds of problems. Not everything fits into these frames, but when you do find them, then if you can ask deeper questions, it's really, really helpful. If I have, just to give you a quick overview of this, a work piece is like, really my problem is I need to build a tool that allows users to create and manipulate things in the world. So I'm going to give you an example of just email. So I may have an email client, right? And so we'll get to some of the questions you might ask. If I have a transformation frame, and they might exist in the same problem, these multiple frames, I have to convert something according to certain rules. And so I think about my decoding and uncoding and all that kind of aspects of mine, just for example. If I have an information frame, he talks about it's designed, for him it's quite different than the way I had thought about it before. It's stuff that you observe that you have to derive that drives behavior. And so, for example, what's junk mail if you had a mail client, or what is what's the rating of bad words that are in an email? So don't let your kids get those or whatever. And then there's this commanded behavior where you're controlling something according to user commands, like sending email. And then there's all this behavior of how do you know that command really worked? Wouldn't it be really nice when I sent email that I know that it actually got delivered? But I may or may not, so there's all these kind of questions. And then he says, well, there's required behavior. You absolutely have to do this stuff. So most of what systems I've worked on have not been required behavior, unless it's like an oscilloscope. But here I might want to sort incoming mail according to filters, right? Got to do that. So one of the things, and I'm just going to show 2 of them just to get a flavor of it. If I'm looking at a transformation frame and I see that characteristic in the problem that I'm working on, I can ask a set of questions. What happens when you encounter errors? Should you you can just go down a rat hole. Is it lossy? Is it reversible? It makes the problem harder or easier depending upon all this. Are there trade-offs in speed, space, and time? Do you care? If I'm thinking about information frame where I'm trying to derive information from the stuff that I get that streams through some, how much computation can I do? How precise do I have to do? Do I have to deal with historical stuff? Do I have to explain how I derive that information? That's hard. So just to give you, so problem framing to me has been always a lens that I can look through and look at my designs. So I'm going to talk about some useful ways, I think, to look at your design and your code and sort of switch streams here a little bit and talk about Christopher Alexander's work, because I've been spending a lot of time in the pattern community for the last 10 years, and there's some pretty deep stuff here. So Alexander, besides introducing us to the idea, the software folks that started it, to the idea of patterns, he moved on and talked about the nature of order, and he wrote 4 very dense books about this. And my friend Jenny Quillian has a book that's available on Lulu, that's an approachable summary and personal interpretation. That's Jenny there. It's called Delightful Muse. So I kind of recommend that as a book if you're interested in it. But this topic but one of the fundamental ideas is that and he doesn't mean our kind of class. He says there's a class of entities which I call centers, appearing everywhere in space, and he thinks about it in physical space, but we have software space too, at every scale, that has centers appearing in it. And so you say, well, what's the point about that? Well, although the system of centers may be fluid and changes from time to time, and they're dynamic, right? The configurations change. His point is that at any point in time, there's a pattern that you can see. And if they're arranged in a great way, there's this liveliness that happens. It's almost like magic. And he talks about degrees of liveliness. Now, I don't mean actors. Every object is an actor. But there's this sense of liveliness and vibrancy in the structures in the world. And it's pretty profound. Jim Kopleen talks about centers long time ago. So he's been talking about it since 1998. And he's talking about graphical elements. He's very physical in the way he thinks about centers. I'm sure his thoughts have evolved, but I haven't had a discussion with him lately about that. He's thinking in actual software, it depends on what we consider to be the actual equivalent of geometrical relationships. I might have some disagreement with him, but that's okay. That's another heuristic. So he says, Alexander, in addition to this wholeness and centers, also talks about properties of things which have life. So you can characterize or understand them through these properties. And I'm going to go through some of these and illustrate both in the physical world with some photos that I've taken or my colleagues have taken, or my spouse, and also talk about the software equivalences that I've seen as well. And so the idea is not to just be able to identify these characteristics, but over time, use them as a lens to see how lively your designs are and what you think about them. And so, this tree is like, you go to Osaka and everything is alive and magical. So that's a tree that I took. Just sort of like, yeah, things in the world are even alive. So he talks about strong centers where you want to have symmetrical shapes that are complementary to the whole. And so if you look at this here, you see this is a center underneath here, and there are repeating ones down below, and it's kind of, you go there and you go, wow, this is really nice. So in software, I think when you have well-defined roles and patterns of interactions and interfaces, those are centers. I think with responsibility-driven design, we talked about control centers, domain models, right? These entities, aggregates, aggregate roots, and the relationships between them are just as important as understanding their structure. And if we're into class-oriented programming, we have abstract classes, we have interfaces, hierarchies. Certainly algorithms may have strong centers in them, reading algorithmic code. So yeah, and from responsibility-driven design, ancient times, still applies to how you characterize things. You can think of where is the control happening. It could be centralized. It could be more delegated. It is interesting if it's a nice pattern, or completely dispersed. If you have this network of, I'm going to say microservices communicating. Maybe that's today's dispersed view of the world. So another one of the properties he talks about is boundaries. So it's not enough just to have centers, but you want to enclose and strengthen them by having boundaries. Think about the anti-corruption layer is a boundary in domain-driven design. But there's other ones to think about. The idea is that a boundary, making a clear boundary, is something that unites it with the world, but also intensifies the nature of the center itself. So what's inside that boundary is really important. So again, I think interfaces and contractual agreements help strengthen those boundaries. Even tests that define expected behaviors kind of create a boundary. If I have classes and subclasses, inheritance is not evil. It can be done well. Aggregate roots create a boundary around the things that they control. And I talked about that. And I think also the notion if I have a trust region within any sort of complex system where I understand if I can verify and at the boundary validate that this is a trusted request, then I can, within that boundary, focus on doing the action. So that makes the attention inside the center, once I've gotten through this boundary, more easy to focus on. So yeah, domain aggregates. There's Eric will go, oh, is that a good picture or not? I'm talking about the aggregate is a cluster of objects that is treated as a unit for changes. And it has responsibility for managing. So it strengthens, if you use that, what's inside. So another one of the properties of things that have life is alternating repetition. And so if I think about it in software, if I have consistent patterns of collaboration, action, domain entities that are composed of value objects related to other, that's a complex network of things. If I think about even at a lower level, double dispatch, or how I delegate is get the request, gets done. Some of the original design patterns talk about visitors and chains of responsibility, or even the composite in the way you're structuring things to have this repetition. So another property is positive space, where you don't have fragments. So I don't know what that says about transaction scripts, but anyway, let's moving along. Every center has a coherent presence. And it's actually interesting. You need negative space to see positive space, I believe. So if I have objects with a singular purpose, or a module that's singular purpose, or stereotypes in good blends, to me, create positive space. but also this fact that there's this public interface and the private implementation. And I want to have tests for both expected and exceptional behavior. Do not repeat yourself, right? That's good. I won't say that again, but anyway, whole value objects or complete constructors create a positive space by doing that, passing along parameter objects rather than just primitive types. So another property is local symmetry to create coherence. So it's like in a complex system, I have to think about at different levels of scale. And so in some sense, even at the level of writing a method and intentionally naming things is very profound. And that keeping at the same level of detail in a method and factoring it out to helper methods that are at the same granularity is like, that's kind of important. And then we think about symmetry in the way of actions and reversing actions, push and pop or do and undo. Oops, okay. So another one of these properties is good shape. Alexander talks about recursive, compact, coherent centers that enable characteristic properties. So if I have consistent roles and patterns of interaction, a lot of these, original domain or domain-driven design concepts, and also even from back in the ancient Goth Gang of Four patterns, and structuring things and making sure that things are modular, really understanding and separating domains. This is just an example of a simple interface or a structure for a reference application I use to teach domain-driven design concepts and engineering to my students, and I hadn't realized, and there's a Java implementation behind it, and I hadn't realized that there's a symmetry between this kind of model. It's not really important to understand a whole lot about it, but there are two aggregate roots. And how do you really understand these complex relationships between them? It's one of the things we talk about. Subscriptions and orders and things, they're quite different, but anyway. So another one of those properties is this notion of deep interlock and ambiguity, that centers hook into their surroundings, and this is a trick because actually this photo is like this way, right? It's really taken in the water. I go back here, and I just flipped the picture I took to here. So there's ambiguity there. Is it really a tree? No, yeah, it's a tree reflected in the water. So that allows things to be alive, actually. That there's interfaces, but if I depend upon the interface, I don't have to care about the implementation, right? That would be nice. And I can allow for a dynamics, all right? Whatever provides that, what I'm asking for, I'll just go with it. So I'm dependent. There's this interlock. I depend upon something implementing that interface, but I don't depend on it itself. So there's also the notion of roughness in that whatever we do in design has to take in effect and consideration the context of what we're doing it. And it's handcrafted often. So if I think about this nature of roughness, I'm glad, because it will mean that we'll always have job security as designers, because it has to be tuned to its environment. And so my design and programming differs from yours, even though we may agree to the same style guidelines. And so don't be rigid about that. That's okay. And you don't, there's this roughness in even how you apply any pattern or heuristic. You're adapting it to your context. And we're always tweaking things for performance or scalability or aesthetics. And so that kind of roughness, not everything is going to be beautifully, symmetrically, it is kind of magical. And so you may learn about heuristics and patterns, and then you go see them applied in the real world, and it looks a little ugly, doesn't it? Rough. It's not ugly, it's just like the world is more complex, so expect that. So another property is echoes, that you want to have similarity between the smaller and larger centers that exist. And so if I think about it, you find and repeat interfaces, intentional naming, relationships, and ways of decomposing things, and how you handle errors and exceptions. I mean, there's many things that you try to repeat and make similar, and the more you can do that, the more people who have to live in your designs aren't like startled. So then another property, and this is kind of tough to get your hands around, is the notion of the void. It's like there's all this clutter around you, the real world of design, and then you might find some voids. It's not what you return from a method call. That's not what I'm talking about. That's a joke, by the way. It's like there's this calm, amazing center that is defined by all the clutter around it. And if I think about the anti-corruption layer that was trying to preserve the strategic design, that strategic design is that beautiful stuff around which all this clutter exists. And there's a reason for that. That clarity there really is the heart of it. If I look at the Smalltalk collection hierarchy, go back to what I've seen beautifulness, is that there's 3 basic operations that then are implemented by subclasses, and then they get all this behavior for free. That's one of the most beautiful structuring that I've ever seen, looking at classes. So there's also simplicity and inner calm. One of the things I think about is that when things get too messy, I want to refactor, right? And that's okay, I should. And for me, what creates simplicity and calm, it may not be for you, but for me, if I don't use all kinds of frills, that I am sparse about clear code, lack of excessive features in a framework, software that simply works, that's really nice. When you are in touch with your environment and a center that has deep, lively properties, it's connected to what surrounds it and is not cut off and isolated. So when I took this picture, I didn't even realize that there was this guy up there doing something in the window. I was focused on this beautiful tree. And I go, wow, that's connected. So I would say that as designers, you need to be connected to what you're doing and think about it. And that hopefully I've shared some ways of looking at design and thinking about heuristics that can help you be a more thoughtful designer. I'd say, and again, is that periodically you want to revisit your heuristics. You don't want them to become dusty, musty, provincial, but you also don't necessarily want to be the latest fashion trend person either, because that might be sort of bizarre. And as you do this, beware of dogma. I'm a domain-driven designer, but what happens when there isn't any rich domain? What do I do? Okay. Do I always need to do things this way? Do I always need to think about objects? No, functional style is great for me. As you apply your heuristics and think about them, one of the things about dogma is that you're not open to new ideas. I think we need to be pragmatic. Now that puppy had better be house trained, but that we're in this stage of learning and discovery, and while we're doing it, we don't want to forget, what we've learned, but we also want to be learning in the new world and pragmatic about it. So with that, I'd like to say, reshape your state-of-the-art set of heuristics based on what you learn from designing and building things in the world, and that will go a long way. So thank you.